3.6 Graph of functions. In this sessions, we're going to graph a different types of functions by plotting the solutions. So the key thing is we need to recognize the parents graph of the function so that we can uh, predict what kind of shapes going to be coming out for each function. First, let's take a look at our linear function. Linear function can be presented in two formats. One is f of x equal to mx plus b, which is already in slope-intercept form already because we can look at f of x as y. So for these situations, we don't really need to find out the solution. We can just use the slope and the y-intercept to graph it. For example, if I have f of x is equal to 2x minus 1, then we know our slope is 2 and the y-intercept is 1. So therefore, I can quickly graph without plotting the points, meaning without looking for the solution. 1, 2, 1, 2, 3, 1, 2, 3. So my y-intercept is -1, so therefore it'll be right here. And then we count the slope, which is go up 2 units, and then to the right 1 unit, which will be another point right there. And if you continue counting the slope, you will get more point, which is go up 2 units, and to the right 1 unit, which is another point right there. And therefore, you can get the equation, the graph of the function quickly without plotting the points. Another case is when you have a functions f of x is equal to k, a number. So this is basically y is equal to a number. That basically mean it will be horizontal line. So we can quickly graph this without plotting the point also. For example, if I say f of x is equal to 2. So this basically say that there is a horizontal line that passes through when y is equal to 2. So 1, 2, 3. And then I can basically graph this quickly without plotting any points, which is going to be like this. Here's a horizontal line at 2. Now the next step is we want to look at the quadratic functions. So when you see that f of x is equal to x squared, when the variable has the exponent 2 and then that is the highest exponent in the formula of a function, then right away we know that it will be a parabola as a quadratic function, and it will be a parabola. So f of x equal to x squared, this can be considered as a parent graph. So you need to remember the shape of this quadratic function, a parent graph of a quadratic function. Because later on, around in chapter 10, we're gonna chapter 9, we will use the transformation to graph quicker, which is very important that you remember your parents graph so that you can do the transformations nice and neat. But for these sections, we're gonna graph by plotting, meaning we need to find out a few solutions. So in this case, I'm gonna pick a few x coordinates and then find out what is the solution is gonna be. So the best point will be -2, -1, 0, 1, 2. And we can basically substitute into the function, which is x is your input, so f of -2, the input, is equal to input square according to the formula. And when you compute it, that will give me 4. Similarly, you can continue computing f of -1 is equal to what? -1 to the second power, so therefore that will be equal to 1. So you may compute mentally or by writing out like this for the rest of it. But these points are the points that you want to remember so that you can quickly draw a parent's graph later on and then do the transformation from here. So here's my point after I compute it. Now we're going to use these points to graph it. So at 0 will be 0 right here, and at 1 will be 1, and 2 will be 4, and a negative 1 will be 1, and negative 2 will be 4. And of course, if you plug in more points, you will get a better shape of the graph. Now, using these 5 points, I'm going to show you how the graph of this parabola is going to look like. So it will be going like this. It will continue going up, continue going up on this side. So this is a graph of a quadratic functions, and this is a parent graph because it's nothing add, subtract, multiply to it. Okay. So let's review a little bit. If you know the function, if you see the graph already, what is the domain of the graph? Right? We talk about in chapter at the beginning of this chapter. So domain in this case is the graph going to be continue extending, and it will cover up entire x-axis. So therefore, it will be what? The negative infinity to positive infinity, because domain is basically talking about the x coordinate. And the range, what about the range? The range is talking about all the y value, right? So in this case, the graph never go below x-axis, meaning there is no negative y value. So it will be, the range will be starting from 0 and then go to positive infinity, and 0 is inclusive. Now that you know the shape of the parent graph of quadratic function, so let's take a look at on the next example. So in this example, we can see that f of x is equal to x plus 4 quantity square plus 1. So if you FOIL this x plus 4 quantity square, then you know that your variable x will have the exponent 2. So that sort of tells you the shape of this function will be a parabola also from the parent's graph. But however, it will not be like, unlike a parent graph, it will not be at the origin to start with. So what we're gonna do is we're gonna try to compute, right, the points and then get the shape of the parabola. So that will be a little bit tedious part that you're gonna be dealing in this section, because sometimes if you pick the number wrong, you will be only seeing one side of the parabola, right? One side of the parabola. So you need to remember your parent's graph so that you can continue plotting the other side and then continue get the shape, the full shape of the parabola. So that will be the difficult, the tedious part that you will run into it. Okay. So let's take a look at on this one. The point that I'm going to be picking in this case will be -6, -5, -4, -3, -2. Right? So if I pick -6, like we did earlier, I can substitute -6 into the functions and then do the computations. So -6 plus 4 square plus 1. So this will give me -2 square plus 1, which is going to be 4 plus 1, which is 5. And similarly, you can continue plug it in, -5, and then continue solving it, continue evaluating it. That will give you the quarter pairs. So -5 plus 4 square plus 1. So this gives us -1 square plus 1, which will become 1 plus 1 equal to 2. So you can continue solving for this, evaluating all the points, and then this will give you 1. Right? When you plug in -4 will be 0 plus 1 is 1, and then this will be 2, and then this will be 5. So this will help us to get the graph of this parabola, and it will be a complete graph. So let's take a look at on this. At -4 will be 1, so which is right here, -4, 1, and then -3 will be 2 right here, and -2 will be 5 right here, and then -5 will be 2 right here, and -6 will be 5, which is right here. So now we get the whole shape of the parabola, and then this is where we get. Okay. And of course, I already know how to choose the points already, so therefore I basically get a very nice, neat graph. Okay. Without figuring out something. So that's what I want you to play, practice a little bit at home, right? Without knowing anything, you plug in the points and then try to get this. And I promise you, we will talk about the easier way, right? Once you go into like chapter 9. But that's how you should be exploring when you're graphing functions. And let's take a look at on the next example, which is looking at the cube functions. Okay, so as you can see, the cube functions is f of x equal to x to the third power, and this will be your parent graph. And notice that the parent graph is never add or subtract anything to it. It's just to the second power, to the third power, and then so on and so forth. Right? So we want to remember when it's a cube functions, how is the graph, the shape of the graph look like? So that, if it is a different formula, but it's still in a cubit, we know when we have an idea how the shape of the graph gonna look like. So in this particular one, you're gonna substitute negative these points, okay? -2, -1, 0, 1, 2. These points. So as usual, you can basically plug it in -2, so that it will help you to compute -2 to the third power, which is going to become -8. And if you can plug it in -1, that will give you -1 to the third power, which is -1 to the third power is -1. And if you finish evaluating for each one, this will become 0, 1, and 8. And that will allow us to see what is the shape of this graph gonna be. So let's take a look at on the parent's graph, the shape of the parent's graph of a cube function. So at 0 will be 0, right? And at 1 will be 1. At 2 will be 8. When x is 2, it will be 8. And then continuing at -1 will be -1. At -2 will be -8. So now we get the shape of the graph. So you have to be careful on this middle 3 points. A lot of times we connect like a straight line. But however, if you plug in more points, okay, between the x values 0 and 1, or 0 and -1, it will be a curve, not a straight line. So therefore, when you graph this cube function, you have to carefully curve this like this. It will be a curve going up like that, and then it will be a curve coming down like this on the sides. Okay, so this is the shape of the cube function. So now that we know what does the functions look like, so let's take a minute to talk about domain of this cube function. And you can see that the cube function, the graph going to be continue extending to the right and then up and then to the left and down. So eventually this graph going to be cover the whole entire x-axis. So therefore, the domain of this cube function is -infinity to +infinity. And also, when we look at the range, right? When we look at the y values, the range, And the graph is also what continue going up and then continue going down, and it will eventually cover up the entire y-axis. So that will be what my range will be, also from negative infinity to positive infinity, which is all real number. Now let's take a look at on this next example. F of x is equal to x to the third minus 3. So we're gonna try to compute this by putting -2, -1, 0, 1, 2 again, like before. So if I have f of x is now the input is -2, so I have to compute input to the third power minus 3. So -2 to the third power minus 3, that will give me -8 minus 3, which is -11. And the next point, if I compute it, f of -1, that will become -1 to the third power minus 3, which is -1 minus -3. That will give me -4. So I have the value -11 and -3 so far, or -4 so far, right? And if you finish evaluating the rest of the point, when x is 0, that will be -3. When x is 1, it will be -2. When x is 2, that will be 5. So let's plot these points to continue graphing this cube function. So we already know the shape of the parents graph, which is like a, the S shape, right? The parabola cut it in half and then the other way around flip it. So let's go, and when x is 0, it will be -3, so which is right here, 0, -3. And when x is 1, it will be -2. When x is 2, will be 5. And when x is -1, it will be -4. And when x is -2, it will be -11, so which is around right here. So now you can see that here's the middle 3 points. So you have to remember it will be a curve going up like this, and then it will be a curve going down like this, and that will be the cube function. So I'm gonna sort of give you a preview of what we're gonna talk about in chapter 9, right? So this is my parents graph. This is my y value. When y value gets subtracted by 3, notice that the entire graph shifts down from the original graph. The entire graph shifts down 3 units. So that is the transformation from the parents graph. That's why we need to know the parents graph for chapter 9 later on. Okay. Now let's continue and look at another type of function, which is the square root function. The square root functions, you won't be able to pick the point randomly like in the previous two different type of functions. The reason why is because the square root have a restriction, which means remember that square root of a negative number is not a real number, so we cannot graph that. So first thing that you want to do in a square root function is find out your domain first. Okay, one, you need to find domain. So domain of the functions tells you how to graph. Domain is basically, we already know from the conceptual part, the square root. Inside the square root, that cannot be a negative number. That inside part is called radicand. So the radicand must be greater than or equal to 0. So from here, what we can do is, my radicand for this case is x, so x is greater than or equal to 0. So my domain will be from 0 to positive infinity. And this tell us where my starting point of the square root function is going to be. So this 0 is your starting point. You have to start with 0 for your x. So that's where you're going to put your 0 right there to start computing. And you're going to be picking the number that are to the right side of it. And this radical function, square root function, is a parent graph. So later on, when you have a square root function, you know how the parent graph is going to look like, right? So let's continue looking for this. So the next point that I want to pick is when the x value will give me a perfect square number. So it'll be 1 because square root of 1 is 1. And then I will not pick 2 because square root of 2, without calculator, I will know what is the outcome is. So I will pick a good number, which is 4, because square root of 4 will be 2. And then the next number will be 9 that I will pick. So like before, I can basically substitute f of 0 and compute it, which is square root of 0 is equal to 0. F of 1, that will be square root of 1, that will be 1. F of 4, that will be square root of 4, which is going to be 2. So now we got 0, 1, 2, and then 3 as our function values. So what we can do is use these points to get the shape of the parent graph of this square root function. So at 0 will be 0, at 1 will be 1, at 4 will be 2, and then 9 will be 3. So you can see that the graph is going to be going to this direction. So it's like, parabola sideways, but only half of it. We will talk about this, the relation between these square root and square, and then cube root and then cube more later on after we talk about the inverse function. So we already got the domain already. Domain is, notice that from 0 to positive infinity, that's what we got. And then the range is basically what? Starting from 0, right? My range is going to be starting from 0 to also positive infinity, because the graph will be only going up, not going down below the x-axis. So when you talk about square root functions, first you need to find out your domain. Second, you're going to use the starting point to plot the points in, and then third, you will be graphing it. So that's the format that I want you to follow. Okay. So remember, how do I get domain? The radicand must be greater than 0. That means the expression inside the square root must be greater than or equal to 0. That's how we find out the domain of square root function. And then this concept will extend it to find out fourth root, fifth root, sixth root once we get into chapter 8. So let's take a look at on another example. So now I have this. F of x is equal to square root of x minus 2. So right away, because of the square root, I sort of know the picture, the shape of the graph gonna be, right? It's only like parabola halfway. And now, what we want to do is like before. First, we want to find out the domain of the functions. Okay. And how do we find out the domain? Because square root function is a restrictive function, meaning you cannot choose any every x value that you want. So first of all, you want to find a domain. Domain is radicand, which is greater than or equal to 0, because in the side the square root cannot be negative. Right? In this case, the radicand is x minus 2. So if I solve for this inequality, I know which x value I need to use, which is the x value must be starting from 2 and then go to what? Positive infinity, meaning x is greater than or equal to 2. So now that I know my starting point, right? So I know that this will be your starting point for this radical function. So I have to start from 2. And after that, I will choose good numbers to continue getting good numbers. So let's compute f of 2 first. That will be f of 2 is square root of 2 minus 2, which is equal to square root of 0 is 0. So we got that. So what is the next number that I need to pick, which is greater than 2, and also it will give me a very nice neat number. So we know that from the square root, this is what we have, right? Something minus 2 will equal to a very good number. So the next perfect square number after 0 is 1. So now I need to think about what minus 2 will give me 1. And then that must be also greater than 2. So the next number will be 3, because 3 minus 2 will give me 1, and the square root of 1 is 1. So I got that. Similarly, I have to continue going. What is the next number? That's how I want to find it out. And the next perfect square number greater than 1 will be 4. So now I have to think about, hey, what number minus 2 will give me 4? That will be what? 6. Right? So the next number that I need to pick will be 6. That is okay because 6 is greater than 2. It is in our domain. So which will be 6 minus 4. 6 minus 2 is 4. Square root of 4 is 2. So now tell me what is the next number that I need to choose, right, to get. So similarly, the way that we're going to be considered will be the next perfect square number that is higher than 4 is 9. So it must be what? 11. So that's another number that I will choose. So this is how you can figure out what number to pick. It's better. So now that we got the order pairs already, we're going to graph those. So at 2, when x is 2, y is 0, right here. When x is 3, y is 1. When x is 6, y is 2. And when x is 11, y is 3. So it will be approximately right here. And then you can see that my graph is what? Going to this direction. So notice that from the parent's graph, when you are subtracting x by 2, it moves the whole entire graph shifted to the right 2 units. And that is the transformation that we're going to use later on. Okay? So now continuing this, once again, let me re-summarize it before I move on. So to graph square root graph 1, you're going to find out the domain. So that will help you to see where your starting point is, and then use the starting point to get the order pairs, and then use that order pairs to graph it. Those will be the step that you want to follow. The cube root function. Okay, square root now is cube root. So for the cube root functions, since it's a cube root, there is no restriction like in square root. You can have either a positive or negative value inside the cube root. So my domain is all real number. But however, you want to make sure you want to follow the easy way. So first step that you want to do is find out the center. Okay, so the center of the cube root function is always, the center will be always the x value makes the radicans equal to 0. So where is the center? It will be the x value that make the radican equal to 0. So in this case, what is my radican? My radican is x. So which value is going to make it 0 when you solve for it? Then x is equal to 0. So that's how I know that my center will be 0. Here's the center. Okay. And then what you do is you pick the number left and right of the center to get a better graph. So here, graph of 0, that will be cube root of 0, which is equal to 0. And we will talk about these cube root functions again once we get into radical chapter, which is chapter 8. Right now, this will be a preview. It may not come up in your homework for practice, okay? But I want you to see it now and then see it again later on so that you get better off it. So the next number that I'm going to pick will be the left side of 0, and it must be a perfect cube number, which is 1 to the third power. Negative 1 to the third power is negative 1. That's a perfect cube number, so I will choose negative 1. So that way it will become cube root of negative 1, that is equal to negative 1. And the next perfect cube number on the left hand side is not 4, not 5, not 6, which is 2 to the third power is negative 8. So it will be what? Negative 8. That will be cube root of negative 8, that is negative 2. So when I pick negative 8, that will become negative 2. Now I'm going to choose on the right side of the 0, the center, right? So similarly, 1 to the third power is 1, so it will be cube root of 1 is equal to 1. And the next number will be 8, because cube root of 8 is 2. So using these points, I can start graphing, which is at 0 will be 0, at 1 will be 1, at 8 will be 2, at negative 1 will be negative 1, and negative 8 will be negative 2. Once again, this is very similar to the cube function, but however, it is like sideways. So the middle 3 point is not a straight line, it will be a curve like we had before. So it will be going like this, and then coming back down like that. Okay. So this is the parent, the shape of the parent's graph of the cube root function. So this is the parent graph. Okay. Now let's talk about a little bit quickly on the domain part. So as you can see, the graph gonna be cover entire x-axis and x-axis, because the graph gonna be extending to the right side and extending to the left side. So my domain will be what? All the x value, which is negative infinity to positive infinity. And then the range, and the graph is not only what? Extending to the right side, it will be extending to the right and then up, and then left and down, so it will eventually cover up the entire y-axis as well. So all my y values, so it will be negative infinity to positive infinity. Now let's use this to graph our next example. So right here you can see that there's a cube root functions, right? So I already mentioned about the step earlier, right? Let me go back and then recall. So step 1, we find the center. Step 2, put the center and then find out the other order pairs. And then step 3, which is the graphing. So let's find out the center. Step 1. The center is basically what? The x value, which make the radicand equal to 0 when the radicand equal to 0. So in this case, my radicand is x plus 2. So therefore, when I solve for this, x is equal to negative 2. Now that we know our center, right? Our center will be negative 2. We're going to start from here. And then we're going to have to pick the point that is the left side and the right side of the center. So like before, let's compute negative 2. So this will be cube root of negative 2 plus 2. That will be cube root of 0, which is equal to 0. Now, on the left-hand side of negative 2, what is the number that I need to pick? So we can basically think about like before, right? What is the next perfect cube number that is smaller than 0? Which is going to be negative 1, because negative 1 to the third power is negative 1. So that is a perfect cube number. So which number do I need to choose so that which x value I need to choose so that the x value plus 2 will give me negative 1. So clearly that must be what? Negative 3, right? So when I pick negative 3, that will be negative 3 plus 2 is negative 1. Cube root of negative 1 is negative 1. So similarly, the next one that we're going to continue is I have these situations, and the next perfect cube number that is smaller than negative 1, which is when we think about negative 2 to the third power is negative 8. So I need to ask myself which x value plus 2 will give me negative 8, which will be negative 10. So this is negative 10 that we need to pick. So that would be negative 8, and then cube root of negative 8 is 2. Now similarly, we're gonna do the same thing on the right hand side of the center, right? So I'm gonna have to ask myself one number plus 2, and on the right hand side of 0, what is a perfect cube number? It will be 1. So I need to choose the x value is negative 1, so that will give me negative 1 plus 2 is 1, cube root of 1 is 1. And then the next number that I need to choose, right? The next x value that I need to choose is what? How do we figure out what is a perfect cube number that is greater than 1? 2 to the third power is 8, so the next perfect cube number must be what? 8. So I know that 6 plus 2 is 8, so I have to choose 6. So 6 plus 2, 8, that will be 2, and this is how I got the perfect cube numbers. So now that I got all these points, I can basically start graphing. So my center is negative 2, 0, which is right here, negative 2, 0. And on to the right will be negative 1, 1. And then 6, 2. On the left will be negative 3, negative 1. And then negative 10, negative 2. Negative 10, negative 2. So now, like before, look at the center 3 point. That must be a curve, not a straight line. So you're going to be curve it like this. You're going to be curving like this. Okay, so that is our cube functions. So first you need to look at this, where is the center is, and plot the points in, and then third will be graphing it. Next, absolute value function. Absolute value functions are very easy to remember. Those are a V shape. This will be the parents graph of the absolute value functions. Again, to find out the absolute value functions, you need to find out your where the vertex is, the center is. So this is the point that we're going to be picking: 0, negative 1, negative 2, 1, 2. So if I plug it in, negative 2, that will be absolute value of negative 2. Absolute value of negative 2 is positive 2. If I plug it in negative 1, absolute value of negative 1 is 1. So when you substitute all the value, this will give out these number. So from here, I can basically graph it as 0 will be 0, 1 will be 1, 2 will be 2, negative 1 will be 1, negative 2 will be 2. Notice that it is a V shape that we are getting. So absolute value graphs are V-shaped graph. So you can see that the domain of this parent graph, right? The domain of this parent graph, notice that the graph going to be extend to the right hand side and extend to the left hand side, so it will be covering up the entire x-axis. So it will be negative infinity to positive infinity. My range, the graph is only extended to upward, not to the downward, not below of x-axis. So my lowest y value, my smallest y value will be 0, and then continue extending to the upward. So it will be positive infinity, and then 0 is inclusive. That will be the range. Finally, we want to look at the type of how to interpret it, the graph of a functions. So now I'm giving to you this graph of a functions f. We want to find the domain and range of the function. So I cannot put the arrowhead, so make sure you put the arrowhead right here for me. And then also this is not, the left hand side is not arrowhead, it's an end to it right there. So that's a big difference, because on the left hand side it will stop right there. Because I put the right hand arrowhead on the right hand side, it's indicate that it's going to be continuing to the right side and then up also. Okay, so to consider domain, we are talking about what, all the x value right here. So when you look at the graph, the x value, you don't have, the graph is not extending after x is -5, right? Left side of -5, the graph is not extending anymore. So my x value is starting from -5. That's where my domain begins, right? The smallest value of x we can have. And then it continue on the right hand side. Notice that I put an arrowhead, so it will be continue extending to the right, so it will be going to positive infinity. So it is very important that when you draw those graphs on the previous example, you put the arrowhead at the end, right? That will indicate that it will be continue extending out. And then my range, now I'm talking about the y value. So notice that we don't have any graph after when x is what, -2 right here. So the y value will be, the smallest y value from the graph that we're going to get is -2, and then since the graph continue extending to the top, so it'll be going to positive infinity, so it'll be -2 to positive infinity. Now the next thing, that next example that we want to find is when f of -3, meaning when your input is -3, what is your output? So I need to look at where my input is -3. So when we go to the x value -3, here's -3, okay? And then that will help us to look at where the graph is. And then this looks like it's going to be what, approximately -1 and a half. Okay? So this is -1.5. So therefore, so notice that the graph will always reflect back to where your y value is going to be, where your x value is going to be. So when the input is -3, my output will be -1/2. So my answer in this case will be f of -3 is equal to -1.5. That's my y value, my output value. So next, what we want to look at is find the x value such that when your f of x is equal to 2. That means, another way of saying is, when your y value is -2, what is your x value? Question mark. So we look at where my y value is 2. Here's my y value 2. And if we continue, I can see that here's a point y is 2. And what is that x going to be? And here's another y value is 2. And what is my x going to be? So now I can find it out, right? The x value for this situation is going to happen will be when x is 2 and when x is equal to what? 5. That will give us the y value is 2. And with this example, we conclude our sections.